So question 1, we are told that in an English language test for 12-year-old students, the data is modelled with a normal distribution, mean 45.3, and standard deviation 11.5. Okay, so we're told to find the probability that x is less than 50. So this is just simply a case of plugging numbers into the calculator. So we go to distribution, the normal CD distribution. So because I'm doing x less than 50, my lower limit is minus a few billion. My upper limit is 50, sigma 11.5, and mu 45.3. And I get the answer 0.6586. Okay. Then for the probability between 45.3 and 50, so we've already worked out the probability less than 50. So if we do the probability more than less than 45, so if we think of the curve, we've got 45.3. If we do this probability and take it away from the previous probability, then we're going to be left with the probability that we want in between the two. Okay, so we need to work out the probability that x is less than 45.3. So we can just go back to this, change my upper limit to 45.3, which is 0.5. And then I can do 0.6586, take away 0.5, gives me 0.1586. All right. It's not a mistake to do what I've just done. I didn't need my calculator to do this because I knew the mean was 45.3. So if I'd have just engaged my brain for 10 seconds, I would have known that that is 0.5 because half the people are below the mean and half the people are above the mean. Okay. Find the least raw score, which will be obtained by the highest scoring 10% of the candidates. So we're looking for the probability. So if we want 10%, the highest 10%, that's 0.1. Remember, our inverse normal mode on the calculator only does less than probabilities. So we've got to do 0.9. So if we go back to the calculator and do inverse normal, so the area is going to be 0.9. My sigma is still 11.5. My mu is still 45.3. And that gives me a mark of 60.03. All right. The raw score is then scaled. So the scale score is normally distributed with a mean of 100 and a standard deviation of 15. The scaled score is then rounded to the nearest integer. Find the probability that a randomly selected child gets a rounded score of exactly 111. So we've got x is normal with a mean 100, standard deviation 15. And we want the probability that x is less than 111. But this is really important. The data has been rounded to the nearest integer. So we're now looking at discrete data. You can't get a score of 111.1. You can't get a score of whatever. Okay? Oh, sorry. This isn't the probability we want. We want the probability that x equals 111, don't we? Okay? Sorry, we should do this. I did this with my year 11s last lesson and we liked it. When you see a mistake, tell me. All right, and we'll keep a track and see how stupid I am by the end of the videos. So we want the score of exactly 111, but this is integer data. So 111 is above the mean, so 111 somewhere here. So we've got to look for everybody between 110.5 and 111.5. Remember, it's that continuity correction. So we are looking for the probability that x is between 110.5 and 111.5. So we do the probability that x is less than 111.5, take away the probability that x is less than 110.5. And then what happens here? Menu 7, 2, lower limit is still minus a billion, upper limit 111.5. Sigma is now 15, mu is now 100. So we get this one to be 0.77836, take away 0.758036. So 0.77836, take away the previous answer, 0.20. 020. Thank you. That's even just not reading numbers on a calculator screen. That's worrying. Okay, then part 4. So in a mathematics test for 12-year-old children, the raw scores are normally distributed with a mean mu and standard deviation sigma. Given that the probability y less than 15 is 0.3, and the probability that y less than 22 is 0.8, find the values of mu and sigma. Okay, so we've got this area here being 0.3, and on my curve it's equal to 15. Okay, then we think about it on the standard normal curve. Okay, so remember, on the standard normal curve, I've got this to be 0.3, and I've got a number here. Now I can actually work out what this number is, because using my inverse normal, the area is 0.3, sigma is 1, mu is 0. That's the, sorry, can't see that. That's the standard normal. So this gives me a value of negative 0.5244. So the 15 connects to this number. Then we do the same with the other one. So we've got an area to be 0.8, and not on my curve, that's 22. And we just need to work out what that is on this curve. And on the standard normal curve, that's 0.8416. Okay, remember 4 significant figures if you're not told what to round to. Then we use our Z formula. So Z equals X minus mu over sigma. So my Z value for this one was negative 0.5244, and that equals to my X value 15 minus mu over sigma, and sigma is something we don't know. And I can write something very similar for the second equation. 0.8416 is the Z value, 22 minus mu over sigma. Okay. Then we've got 2 simultaneous equations in mu and sigma. So I'm going to multiply both sides by mu and then add the mu to both sides. Okay, so I end up with 2 equations, negative 0.5244 mu, sorry, sigma plus mu equals 15, and 0.841